Hello and welcome back. Let's learn how to solve this problem. We are given LaTanya will walk her bike from her house to the bike shop, which is 1.5 miles from her house, to get the bike fixed. She expects to wait 30 minutes for the repair. Then she will ride her bike home. Can she be home in 1 hour? Okay, there's a lot of information here, and there's also a nice map that shows us that she went from home to the bike shop and then back. We can also see the rate at which she traveled in each direction. We know how far it is from her home to the bike shop when she travels along this path. Can we find out how long it takes her? Yes, we can. Recall that distance is equal to rate times time. So that means that if I know the speed at which you're going and the amount of time for which you're going at that speed, I can figure out how far you went. I just do the rate times the time. On the other hand, if I wanted to know how long it takes you to go some distance, knowing that you're going at some speed, we can figure that out too. So let's say I wanted to figure out time. What would I do to isolate t? Divide both sides by r. So then time is equal to distance divided by rate. So let's use that. Okay, so on her way to the bike shop, we know she goes 1.5 miles. That's our distance. That's our D. So we have 1.5 miles divided by, and then at what rate did she go? Well, she was walking. She went 3 miles per hour. 3 miles per hour. Okay. What else took up time? Well, she waited 30 minutes for the repair. How many hours is that? 0.5 hours. And then what happened? Then she rode the bike home. So she went the same 1.5 miles, except now the rate was 10 miles per hour. Okay, so how many total hours did it take her to make this round trip? Well, 1.5 divided by 3 is 0.5 hours, plus she waited 0.5 hours, plus 1.5 divided by 10 is 0.15 hours. So what's that total? 0.5 plus 0.5 plus 0.15 is 1.15 hours. So can she be home in 1 hour? Nope, she cannot. And we're done.